My name is Arun Gupta. I am a Vice President and General Manager of the Open Ecosystem team at Intel. You can learn about us at open.intel.com. You can also follow us on Open at Intel on Twitter or X. And we have a wonderful set of podcasts that are also available on open.intel.com. So please follow us along. Today, we are continuing in our Sapphire Rapid on AWS series. What is Sapphire Rapid? What is it doing on AWS? We'll dig into that. But first of all, let me introduce Robbie. Hey, Robbie.
Hey, Aaron, and welcome to Oregon since you're here today to record this one. Uh, yeah, I'm a senior PE in the Xeon Software Group, and I drive our software engagements with AWS. So, yeah, great to be here.
Excellent. So this has been, well, thank you, first of all. I'm really happy to be here in Oregon. Um, we have been doing this Sapphire Rapid on AWS series. So let's bring it back together for the customers and the developers. What is Sapphire Rapid? What is M7i, C7i on AWS?
Sure. So, Sapphire Rapids is our fourth gen Intel Xeon processor. The SPR or Sapphire Rapids was the code name, and that's available in AWS as the M7i, C7i, R7i, and the R7iZ instances. And there's also an M7i Flex instance, which is brand new. And this particular session is a more detailed look at that instance because that's a completely new instance type.
Got it. So this is the fourth gen Xeon processor introduced as a seventh gen on AWS, and that's where the number seven comes from.
That's right.
Okay, so let's talk about the Flex instance and see what this is about.
Okay. So yeah, I mean the most important slide, and I'll skip past it quickly. Uh, okay. Uh, so yeah, putting the link over there for anyone that's interested. You can always search for it. Uh, so these are advertised as the lower cost variant of M7i instances. What and this is a snapshot from the AWS blog post linked above. But what this is really saying is it's 5% better price performance, and they are great for applications that don't utilize all the resources, and they have a baseline of 40% CPU, and they can scale up to the CPU performance 95% of the time. And we'll break that down to see what that really means. What does that look like from a customer point of view, and so on. And these are available from the 2 vCPU, which is the dot large, till the 8XL, which is the 32 vCPU size. So it covers the most popular instance sizes effectively, and all of them have the same network and EBS bandwidth available. There aren't any Flex instances right now with local storage, but I think this is clearly a new instance type. And from the session that AWS had in reInvent about Flex, it's clear that they're looking at what the customer uptake is, learnings from it before they decide to expand this to other instance types.
So at a high level, this is a better price performance for applications that don't consume 100% of the CPU all the time.
That's right. And the underlying processor system is the same as the M7i, so you potentially get the complete goodness of going to the 7th gen Intel-based instance without having to pay the premium.
That's beautiful, actually. And is this the first time that AWS has created like a Flex instance?
Yeah, so this is the first Flex instance, and we'll dig into what other instances might have been similar to this. Let me actually jump right into that a little bit. So, and some of this information is from the AWS session on M7i Flex. I wasn't sure if it was a chalk talk or a breakout session, so it may or may not be available as a recording online, but we'll update it if I do find it. But this is data that AWS published, right? So there are very few customers that really run at 100% or even close to 100% for that matter. The chart on the right is the percentage of instances that have utilization at various levels. And as you can see, it's really between 0 to 20% that the majority of instance types are at, right, in terms of percentage utilization. And there's a very thin, long tail of small percentage of customers that have more than, say, 60% utilization. So the majority of customers are, and for the majority of time, the utilization is relatively low. It's around 10 to 40%. And the reason for this is most customers don't try to go do a deep dive on what is the right sizing for their instances in terms of number of vCPUs, memory, and so on. They generally try to over provision, and it's with good reason because you don't want to violate your SLA. So you would rather err on the side of caution and make sure that your end customers, your applications, your phone apps are responsive, and you are willing to sacrifice a certain amount of utilization for that, right? And that's what leads to underutilization. And what Flex is really offering is for 5% of the time you will get the baseline of 40% performance, which is 60% lower, but you get it at a 5% discount, which means you're now at the same pricing as an M6i or as an M5. Now, there's also spot instances available for M7i Flex, which makes it interesting. So what that means is, and this chart at the bottom is like an example of a spiky utilization that a customer might see. So any point on the chart on the top is probably an average of utilization that actually looks like this spiky graph at the bottom. So if you see this 5% throttling is the word I'll use loosely here, but if you experience that 5% of the time, only when you have hit a spike, then you may see a certain amount of impact. But otherwise, you really don't see any impact. That is, I think, the premise here. And there was previously a burstable instance type that still around, the T instance types. And uh, if you compare the T instances to the Flex, there's a few differences. So the T instances are only available in 2 vCPU to 8 vCPU sizes. This goes up to 32. The T instances actually only had a 5% baseline perf, meaning you could drop 95% of the performance. Here, you don't drop below 40%. And in terms of behavior, there was a fairly complex behavior with the T instances. So if you would accumulate credits if you were using less than the amount of compute that you were subscribed to, and you would burn credits if you were using more, and then you would get throttled, right? And so the Flex instances don't have such complexity. I'm assuming that would have made it easier for the hypervisor policies as well. So it's a relatively more straightforward thing. The 60% low for 5% of the time, that 5% of time, we're not really sure whether it is only the lifetime of the instance that you rent or a lifetime measured as, say, 24 hours or 48 hours. And that's something that AWS has decided as a policy, so you'll have to ask them. And of course, the T instances are even cheaper than Flex, but there is a trade-off here as the other points are calling out.
Got it. So we are basically getting 60% lower performance 5% of the time.
Yep.
And at 5% discount as well. And as the graph shows, majority of the users are actually not using 100%. Actually, majority of the users are in a much lower percentage, or at least good 40% are utilizing it, very underutilize it, and that is because they're over provisioning it. So this is a really win-win for customers that you want to get that performance. We are guaranteeing you a certain performance, a certain point of time, and you can still pay the price that you were paying for M6i.
Yeah, and I think the main point here is uh, unless you really need near saturation of the CPU, or you're running an application that needs a guarantee uh, every single point in time, and you're not really running in a scale out manner where you can do trade that off across multiple instances, you can probably run on an M7i Flex. So let me go into a little more detail on this one, and we'll walk through what a Flex instance looks like as well. Excuse me. So
So what kind of workload would be relevant? Like, if I think in terms of microservices workload, a request comes in, it spins it up, and it's a horizontal architecture. Is that a
right.
good architecture for leveraging M7i Flex?
Yeah, absolutely. So, if you think about it, most of the customers that are running microservices will be doing HPA, or horizontal for auto scaling, or some kind of scale out mechanism, whether it is with Kubernetes or some other mechanism, right? And you will have some trigger or a threshold to decide on when to scale out, right? And you can set that. And most people, if they have a percentage CPU utilization threshold, and you have it set quite conservatively. So you're rarely going to run into the 100% CPU time unless it's some scenario where you had a limitation in your auto scaling group and there was a sudden spike in your request rate, and the pods and containers that you had on those few systems that you have started to get saturated. It can happen. It sometimes occasionally does. But if you have this kind of a microservices environment where you can scale out, you can simply use a set of m7i flex instances and then burst to additional ones as you need, and you get a significant performance benefit because it's 5% cheaper for every new instance that you're adding.
Got
And
it.
I think more importantly, the way I look at it is rather than looking at it as 5% cheaper than M7i, which is new, if you compare to M5, which a lot of customers are still on the C5 M5 generation, you get up to 46% higher performance at the same price as in the C5 M5. Because the M6i to M5, there was no price difference, and the M7i Flex to the M6i to the M5, there's no price difference. So you
Wow.
could either get the 46% higher performance or you reduce cost by nearly half by using half the instance size to deliver the same performance.
That's beautiful, actually. And because if customers are leveraging open source projects, open source frameworks, it's just the migration from M5i to M7i Flex should hopefully be straightforward.
Yeah, no, it actually is. And we've done a lot of testing on this one. That's one of the values that we see customers get from x86. If you're still on JDK 8, for example, or if you're on an older version and you're not yet ready to update or migrate, it doesn't matter. Everything will just work. And you can just run the same software stack. Obviously, there's a lot of performance benefits to be gained if you update to the latest version of the kernel, glibc, JDK, and so on. But even if you have that in a plan and you are planning to do it over a period of time, you can run all of these existing versions and get that performance benefit by going to an M7i Flex.
So the recommendation for customers is to basically, if you're running on M5i or M6i, is to move over to M7i as is. You can start as is, and then as you are on M7i Flex, kind of slowly start upgrading your app to get the biggest juice out of it. Because as we are doing in the upstream frameworks or kernel or wherever we are doing it, this allows them to get the maximum benefit out of the accelerators that are sitting in there.
Yes, exactly. So, if you migrate to the latest instance, and every new instance generation, Intel does a lot of performance optimization upstream. And as you plan that update of software versions for many reasons, for performance, for security patches, and so on, you're going to get the benefit of the improved performance over a period of time because there are a lot of software enhancements that keep going in. As an example, the performance of the C5 M5 generation or the C6i has improved over a period of time as you go to newer versions of software. And those are the performance benefits that will accrue to the M7i Gen as well.
Got it. Beautiful. So let's go through your slide back again.
Yeah, and that reminds me, that's probably another topic for a webcast in the future where we can show the perf improvement that's happened over, say, 6 months to a year with these prior generations.
I think that'll be a wonderful topic, where we just bring an existing app, running it on M5i, and say, hey, exact same app, bring it over here. And as you are taking that app, how do you start upgrading each component and performance kind of systematically going up?
Yeah, yeah, no, absolutely. I think we track that for discrete pieces of software in terms of the kernel and for the JDK and so on, and how much performance improves when you go from one to other. We've only done that for a few workloads collectively. So that's a good topic.
Yeah, like a
Whenever I
macro benchmark would be really useful in that sense that, hey, my application was doing 1,000 requests per second on M5i, whatever, and now I'm doing this on M7i Flex, and now it's able to do 3,000 requests per second just because operating system, JDK, your runtime frameworks on top of that, they've all been optimized for the latest hardware here.
Yeah, I think I ended up signing myself up for some more work. Invariably seems to happen whenever I speak to you, Arun. I need to be careful about this.
It's exciting though. Yeah,
Yeah,
well,
yeah,
this is for customer, right? And one of
yeah,
the
absolutely.
Intel core value is customer first, and that's how we say it. So thank you for volunteering for that. Let's get back to the slides again.
Yeah. Now, benchmarks are obviously the wrong thing to measure the value of an instance like this, which is meant to benefit real world scenarios where utilization is relatively low and benchmarks tend to saturate the system. So we had to make some changes in how we measure things. And that is still work in progress, but we've completed a certain amount of work that I wanted to share. Right? And not to put a fine to find a point of it. Generally, when people look at loading, you're looking at spatial loading and not temporal. What I mean is you're saying that you're going to occupy 20% of the course, 50% of the course, and so on. Whereas in this case, it's a factor of time. So what you need is really temporal allocation. So you want a scenario where you're running on all of the vCPUs, but loading 50% of the time and then 70% of the time rather than 50% of the course. That's kind of what I mean. So here we just took two examples: server-side Java and a HammerDB benchmark running against MySQL, which is the most popular open source RDBMS. And we're looking at three different levels of CPU utilization. Again, like I said, it's more temporal rather than spatial, of 25, 50, and 75%. And we ran it for 24 hours each and across a few of the instance sizes to understand how much the performance improves and what does it look like compared to the prior gen and the current gen. And so a little bit of a pie chart of a table, but I didn't want to spread it across too many graphical charts either. But if you look at the first table here, this is the server-side Java. So M5 to M6i, that's the last two generations, there's a 36% improvement. This is on a 2XL, and on a 4XL, it's 25% improvement, and on an 8XL, it's 24%. So, pretty good performance improvement. M5 to M7i, it's nearly 50% at the 2XL size, 24% at the 41% at the 4XL size, and 36% at the 8XL size. And these are great numbers. Now M5 to Flex is very similar. It's not too far away, and in fact, at the 8XL size, you see that it's actually showing up as 41% versus the 36% going from M5 to M7i. Now, this is because of the performance variation to some extent that we talked about, right? But the performance improvement, even with a benchmark, is quite high. Now, the server-side Java benchmark we're using allows us to fix the throughput at a certain point. So we know that for a constant request per second, as an example, measured across these different instances, what is the performance, what is the so we measured it in a few different ways to track both the throughput improvement, the time it takes to achieve that throughput, and so on. So this is the overall throughput improvement that we've plotted here, and obviously the more detailed view will be something that we'll be publishing soon at Intel.com.
This is wonderful. I mean, even though like this is a benchmark, and even though it kind of saturates the compute, but the whole idea here is to show that in that capacity, it can show significant improvement. So if this is part of your application, which is only part of it, but you'll still see improvements.
Right. And the second one is HammerDB MySQL, and we're just running it at different load to ensure that CPU utilization is varying, and it's approximate because it does vary a little bit because we are tuning. We are not trying to just pin to a few cores, although we can do that too, but we're trying to vary the load so that utilization changes. And what you see here is a similar view where you get pretty much all of the benefits of going to an M7i, right, without having to necessarily pay the entire premium, with the caveat or trade-off of having that performance variability 5% of the time, right? And this is true pretty much at different levels of utilization. Obviously, we didn't want to try to test it 100%. We probably would see more of a drop-off if we go to 100% utilization, but that's not really a practical scenario. Almost no one runs in production at 100% utilization. One of the other things that I'll mention is that these flex instances only seem to advertise the 2.4 gigahertz base frequency, but obviously the actual frequency does go up to the same as the M7i instances, because otherwise you won't see these performance numbers. And the M7i had something new which was featured in one of your previous webcasts, which is the core PMUs are available, but those are not exposed on the flex instance. So just two things to bear in mind, although that doesn't have any impact to the performance of the workloads themselves.
This is wonderful, actually. Can we get into the part that how does AWS make this work on their side? Because end of the line is still a Sapphire Rapid instance installed in their data center. How is AWS optimizing this on their data center and giving that cost benefit to customers?
So I'll have to do some guessing. So I have to be careful about what I guess. But what I would say is that given the fact that there is such a varying level of utilization and a relatively low level of utilization, I'm guessing that AWS can get a benefit of lower power consumption. I believe in the Flex session, they mentioned that the power efficiency of this is significantly better. In terms of being a more sustainable option, this is something that is both lower cost and lower carbon footprint. So that's something that AWS can pass on in terms of the savings. That's what I would expect.
Got it. Thank you. All right.
Okay, so let me try to switch to the console and just launch a Flex instance. So I'm in the standard. I'm just using the ClickOps methodology, if you will, just so that it's easier to demonstrate. Uh, just not tagging it as anything right for
Ravi, do
now.
you
Let
mind
me
making
just pick
the
a.
font size slightly bigger?
Oh, sorry. Yeah, let me.
Read. There you go. Much better. Thank you. That's fantastic.
Okay, so let's pick a 4 vCPU instance.
Also, you search for M7i Flex exactly, and then you pick the right instance in that.
That's right. And I'm just going to pick something that I have. I'm going to select my default group. And I'm not going to change any of these things. I'm going to go with the GP3 and launch this instance.
It's been a while that I've seen a EC2 console, so thank you for taking me through the ride.
Yeah, I mean, normally we use the CLI as well, but
Yeah,
this is just easier in a demo.
yeah.
So let me just pick that up. And I should have my WSL.
Make that WSL font bigger as well.
Yes. Good.
Oh, that's wonderful. Seems like the instance is still booting. Oh, there
Okay,
you go.
there we go.
Bingo.
All right. So I'm running Amazon Linux 2023, and if you look at another CPU on this thing, this is what it shows me. So I've got 4 vCPUs. It's an 8488C. It's got support for all of the latest instance features like
That
AMX.
8488 indicated this is a fourth gen Xeon, which is basically
That's right.
Sapphire
It's a 4th gen Xeon, and that's a custom SKU that
custom SKU.
AWS only
Yeah,
AWS has.
yeah.
And yeah, so it's got
And,
a
and sorry,
record.
one more thing. You showed AMX, NT, and AMX. That indicates those are the accelerators that are enabled in Sapphire Rapids.
These are the new instructions, hardware instructions that
New
support
hardware. Right.
different data types that are available. So this is a full-fledged, Sapphire Rapids
Got it.
based instance.
Got it.
Right? And if I look at everything, I mean, memory and so on. But I think just to launch another instance, and I'll pick a same machine image, but I will this time pick an m7i. And just an m7i extra large, just like the Flex.
So we launched the M7i Flex, and now we are launching M7i.
That's right. Okay, so we have a Flex, which is okay. I think this is like too large for me, but anyway. So we have M7i dot large and FM7 flex dot large. We've already connected to the flex, so
Right.
I'm going to connect to the M7i test.
Okay.
This might be more my connection than anything else, but okay, there we go. And I'm on the same thing. And the reason I'm showing you just the LSCPU output is both of these, the Flex and the regular M7i, are going to look exactly the same. If you
Right.
were to provision these two and just not look at the console to see what the difference instance types are and just log into them, you would not see any difference.
Got it.
And the only difference you would really, the only way to really discern what it looks like is, for example, seeing whether the, like if I do a, list, this list of events will be smaller on the Flex. I'm now on the Flex instance, and I'm going to do the same thing.
So at the base, as you said earlier, these instances are exactly the same, just the pricing and the performance characteristics are different.
And as you can see here, that's pretty much it, and it switches after that. So
Wow. Okay. So the list of events is much smaller here.
that's right, and that's pretty much. I mean, there's a few ways to tell. Obviously, you can see in your API call or CLI when you list instance type and so on. But from within the instance, there's very little to actually distinguish these two, other than the behavior that AWS controls.
Got it. Got it. Now, this M7i Flex instance, could this be used anywhere, like as a Kubernetes worker node, regular EC2 compute instance, wherever EC2 images could be used?
Yes, absolutely. I think one of the things that I would suggest is that these are okay. So I don't actually see a limitation in terms of where you would use, other than, of course, where you don't ever want a scenario where your 5% of the time impact happens when there is a spike in your workload.
Yeah. Yeah.
And so what we are seeing, and nothing is better than a production test, and we have been talking to a lot of customers that are trying it out, right? And what we see is that there are many customers that assume their utilization was much higher or might be impacted by this, that where they don't really see an impact. And the other is customers that have had to deploy much more granular, detailed tracking to get a better understanding of where they're at, so that they can actually get the benefit. So
Got it.
in general, the reason why I'm saying that you go from C5 M5 to M7i is because the price performance trade-off is so stark, right? I mean, it's not that M6i to M7i Flex isn't a performance improvement. It is absolutely a performance improvement, as these numbers are showing you. But going to an M7i Flex from an M5 is like a no-brainer, and you can do it without needing to change anything in your software, and then update your software as time passes. So that's something that I think is straightforward for a lot of people to consider.
Got it. And then because of the compatibility and everything else, the transition, if you're using infrastructure as a code, like a Terraform or a cloud formation or anything like that, is just changing the right data type and deploying your infrastructure all over again, in which case you'll just recycle your hardware.
That's it.
Beautiful. Let me make the slides go away. Ravi, that was wonderful actually. I've always been wondering about this flex instances, so I learned a lot, and hopefully the people on the call learned a lot too. Is there anything I should have asked you that I didn't ask today?
No, I think we covered almost everything. I think this was good. And there again, I encourage you to check out the M7i Flex instance session from reInvent. I think it was CMP 204 or something like that. I actually couldn't find the recording posted yet. Maybe it just hasn't been posted, or if it was Chalk Talk, we'll try to reach out to the people that did that talk and see if they could share some of the content. But that was a really good one where I think AWS shared, like that chart that I showed,
Got it.
the level of utilization and so on. So,
Wonderful. And then once the link is available or the recording or the slides, we can actually post that as part of the LinkedIn request itself right here.
yes.
Awesome. Thank you, Ravi. I really enjoyed it. Take care. Bye.
Okay. Thank you. Bye.
Bye.